Wormholes, black holes, and negative mass. What does all of this have to do with the birth of the universe? All this and more on today's Into the Multiverse.
This is Into the Multiverse with Josh Peck.
Hey everybody, hope you're having a good week. Man, last week that interview with Zach Drew was phenomenal, wasn't it? He is awesome. Well, today we're going to be talking about black holes, wormholes, negative mass, and we're going to be talking about something that I predicted was coming along in the next few years, and I said that a few years ago. This idea that the universe is eternal and that it was never created. There was never a beginning point. I have talked about that before, but now physicists are actually talking about this as if it could possibly be a reality. We're going to talk about how it's impossible for that to be a reality. The universe was created at some point in the past. This has a lot to do with black holes and wormholes and things like that. So if you haven't had a chance to do so, make sure you subscribe to this channel, click the bell for notifications, and if YouTube doesn't notify you, just know that every Thursday morning at 9 a.m. Central, you will get a new episode of Into the Multiverse. Also, email me at jpeck@skywatchtv.com if you have a question or a comment. If you have a question that you would like read on the show, if it's a good question, if I like the question, and if it's something that I know something about, then I'll be happy to introduce a segment, a viewer Q&A segment. So jpeck@skywatchtv.com is the email address if you have a question or comment about Into the Multiverse. Okay, so the first thing that I want to look at here, and because I thought this was kind of interesting, physicists just released step-by-step instructions for building a wormhole. Now, of course, like these things typically tend to be, that title is a little clickbaity because we don't have the technology to do anything that this step-by-step guide, proposes. But it's still interesting science, and it really goes into the nature of wormholes, what wormholes actually might be. I think that they might be a passage to another dimension. When you read the book of Ezekiel, they're described as whirlwinds. And actually, a good friend of mine, Jim Wilhelmsen, said, well, imagine if you take a whirlwind and you tip it on its side. What does that look like? And I said, well, that would probably look like a wormhole. And he said, there you go. If angels are coming through these things, higher dimensional entities are coming through these things, maybe that's what wormholes' purposes actually are. So it's really interesting to think about. But we as human beings, we wonder about wormholes, we wonder about black holes. And they are two different things, but there's a lot of similarities too. And we're going to look at some of those a little bit later. But this story said, and this comes from livescience.com. You can find the link right up there if you want to find the story. But it says, everybody wants a wormhole. Who wants to borrow or who wants to bother traveling the long and slow routes throughout the universe, taking tens of thousands of years just to reach yet another boring star, so on and so forth. But it says there's a small technical difficulty. Wormholes, which are bends in space-time so extreme that a shortcut tunnel forms, are catastrophically unstable. As soon as you send a single photon down the hole, it collapses faster than the speed of light. So a common depiction of a wormhole, if you're brand new to this concept, a common conception that you'll see in movies and things is they'll put 1 point on a piece of paper here, 1 point on a piece of paper here, and then fold it and poke a hole through with a pen. What they don't tell you is that's not exactly what's going on. That's how a wormhole would work in a two-dimensional universe. If you had just a flat two-dimensional universe where there is no up or down for that universe, you could make 2 points and then fold the universe, into the third dimension. Again, for any entities living in that universe, they're two-dimensional, so they wouldn't know that really any kind of folding is going on. But that fold could happen into the third dimension, and then those 2 points can meet, and then that would be like a wormhole. So instead of the two-dimensional being having to travel all the way around, it could just go through the wormhole. So the same idea applies with wormholes in our dimension. It wouldn't be a circle. Exactly. It wouldn't be a circle the way that it's depicted in movies. It would actually be a sphere. So a wormhole would really be like a worm sphere, really. But it'd be a three-dimensional sphere, and it would curve through the fourth dimension, if there is one. I believe there is. Many physicists too. The fourth spatial dimension. We're not talking about time here. even though space and time are interlinked. But it would curve through the fourth dimension that we can't perceive. So to us, if you're going through a wormhole, you just arrive someplace faster than you were supposed to. What's interesting about this is there are miraculous stories that people have reported where they're driving they're supposed to be driving a long time. They're driving across the country, and they end up getting there somehow days before they were supposed to. We interviewed one of our very first episodes of Into the Multiverse. We interviewed Bruce Gernon, who is a pilot. He traveled through what he described as a wormhole, and he was actually able to prove that something strange happened because when he arrived at his destination, the gas that was used in his plane would not have been enough gas for him to arrive at his destination. So something strange happened there. He's written books on this, and he's done a bunch of interviews about it. And so something is going on. I believe that this type of thing is possible, and it's possible that these can be stabilized. But again, I think it's really difficult. I think it almost has to be something miraculous. I think for us, it's nearly impossible to create a wormhole. But for a higher dimensional being, I think it would be a lot easier. Just like we would have a very easy time folding two-dimensional space and creating a wormhole for two-dimensional beings. It'd be really easy. Imagine how difficult that would be for a two-dimensional being to do that in their own universe when they have no concept of up or down. How would they fold their own space? I mean, it would be impossible. And they would only have two-dimensional physics to work with. They would only be able to develop two-dimensional technology. They would be extremely limited. So I think higher dimensional entities can create wormholes into our dimension, but it's a whole other thing to suggest that we could do the same thing. I don't know how possible that is. But nevertheless, I do think they exist. So anyway, so in creating wormholes, that's what this is talking about. So it says in a recent paper published to the preprint journal ARXIV, I've never known how to say that, ARXIV, on July 29th has found a way to build an almost steady wormhole, one that does collapse, but slowly enough to send messages and potentially even things down it before it tears itself apart. All you need are a couple of black holes and a few infinitely long cosmic strings. So here's where it kind of talks about wormholes in principles. It says, building a wormhole is pretty straightforward. According to Einstein's theory of general relativity, mass and energy warp the fabric of space-time, and a certain special configuration of matter and energy allows the formation of a tunnel, a shortcut between two otherwise distant portions of the universe. If we really wanted to create a wormhole, what we should do is first, even in simulations, but first find out how a two-dimensional being would bend their own two-dimensional space into the third dimension. If we can figure that out, then maybe we can figure out wormholes. But that would be a good place to start if they're wanting to do this. Now this is only wormholes through three-dimensional space. This is not wormholes through, into a higher dimension. I do believe that those exist. Those can exist. Just like if you had the two-dimensional plane, right, and you had the 2 points, but you only instead of bending it for the points to meet, you only bend it up part way. Then if they travel up there, if they travel up to that other point, then that point would lead to another, really that would be another universe. If you bent it this way, so, kind of like that, up and then back over again, so they would have access to up and down, then that would be a new dimension. But again, they're two-dimensional beings, so any new dimension you give them, you're taking away one of their dimensions. It's just like if you have a flat piece of paper and you turn it up on end, it doesn't become a 3D object. You're just trading, width for height. That's all you're doing. So all of that would have to be taken into account if they were to ever develop some type of simulation to see how this would be possible. But if they were able to figure out a way, even just mathematically, that a two-dimensional being could bend his own space and create a wormhole, they should be able to apply that to three-dimensional physics. But again, it'd be very difficult. But that's kind of what they're talking about here. So it says, unfortunately, even on paper, those wormholes are fantastically unstable. Even a single photon passing through the wormhole triggers a catastrophic cascade that rips the wormhole apart. However, a healthy dose of negative mass, yes, that's matter, but with an opposite weight. That's not exactly, okay, that right there is not an accurate description of what negative mass is. I don't know why they phrased it that way, but mass is not weight. Like, mass isn't matter with an opposite weight. It's possible they were trying to kind of like dumb this down for people, but mass and weight aren't the same thing. Weight is just the attraction of gravity, the force of gravity on an object. Mass is the substance of something, and really even saying that isn't accurate. Mass is more like, you could compare it more to like electrical charge. There can be a positive and a negative. Mass is an interaction with what's called the Higgs field. So the Higgs field, it's all around us. It's everywhere. You're interacting with it all the time, and when you interact with it, that interaction is mass. You also need velocity, though, so you need to be moving through it. That's why the faster you travel, the heavier you get. You know, the closer to the speed of light that you get, the heavier you get. That's why light speed is impossible for objects with mass, because there comes a point where you have infinite mass, basically, and you can't have that. Well, why would velocity have anything to do with speed? And also, how are photons massless? How can something be massless yet exist? It's because we have our idea of mass isn't right. Like, for something to exist, it needs to be something. It needs to have some sort of substance. So even saying mass is substance isn't exactly right. A photon is able to exist because it doesn't interact at all with the Higgs field. It does not interact with it whatsoever. So it's like putting a magnet next to a piece of wood. There's no magnetic interaction there. Now, things with positive mass, which is, either things are massless like photons, or things have positive mass. We don't know of anything that has negative mass, but it could exist. Things with positive mass have an interaction with the Higgs field. So the same could be said about an object with negative mass. It would just be like positive and negative charge, or just like how you have two magnets and you can stick them together, but if you turn one of the magnets over, then the charges don't match and they repel each other. So that's a good analogy of how negative mass works. It's theorized you could develop a substance, and actually I would have to look into this, because I think they did actually develop a type of liquid that has negative mass, that when you push on it, it pushes back instead of following the force that you're exerting on it. It pushes back against the force. So really weird stuff, but it's not totally crazy. It just means that we need to redefine what our understanding of mass is. Mass is it's an interaction. You can have a positive, you can have a negative. It's like magnetism or electric charge. There are ideas that gravity is like that too. That there are, and we've talked about this in past episodes of Into the Multiverse, and in the white holes episode, where there's an idea that you could have the opposite of a black hole, where instead it sort of has this like anti-gravity effect, or negative gravity, where it pushes things away rather than bringing them in. And so it's not totally crazy. Describing negative mass the way they did here as matter but with an opposite weight, that's not correct. That's not right. But it says, can counteract the destabilizing effects of regular matter trying to pass through the wormhole, making it traversable. So if you put negative mass in with this, or probably more specifically negative gravity, but that might just be in terms of black holes. If you involve some type of negative force to counteract the devastating forces of the wormhole or the black hole, then yeah, it could be traversable. There have been theories put out that the rotation, again, remember, a black hole is a sphere. A black hole isn't just like a two-dimensional hole that's just there. It is a sphere, and it does have a spin. It does have a rotation. There are ideas that if the rotation was strong enough, if the centrifugal force was strong enough in that rotation, it would counteract the extreme gravity, and then you could traverse the black hole or the wormhole, depending what you're talking about, with that. But so there are already ideas about this, and that's not the same as negative gravity. That's just a different type of force. Centrifugal force is just a different type of force that can counteract gravity. That's why the moon is where it is in orbit. That's why it doesn't come crashing into the Earth, but it doesn't go flying out into space either. It's what's called equilibrium. The centrifugal force is pushing the moon out, but the gravity from the Earth and the moon are pulling it in, and it reaches a point of equilibrium where due to the distance, the force, the centrifugal force is equal to the gravitational force. So that's why it is where it is. That's how everything in the universe that orbits, that's how it works. Matter with negative mass doesn't exist, so we need a new plan. Again, I don't know if this is accurate. It seems like a while ago I did a story on a team that did create a negative mass fluid in the lab. I might be wrong on that, so I'll have to look into that again, but it says, so let's start with the wormhole itself. We need an entrance and an exit. It's theoretically possible to connect a black hole, a region of space where nothing can escape, to a white hole, a theoretical region of space where nothing can enter. When these two odd creatures join together, they form a brand new thing, a wormhole. So you can jump into either end of this tunnel, and instead of getting crushed into oblivion, you just harmlessly waltz out the other side. But white holes don't exist either. Man, this is getting tricky. See, again, this is a publication that does try to kind of dumb things down for average readers, which is fine. There's nothing wrong with that. But it's not accurate to say white holes don't exist. We don't know if they exist. The mathematics that say black holes exist, they work for white holes too. And we know black holes exist. We've detected them. We even took a very blurry picture of one of them. We know black holes exist. That's been proven. The mathematics that predicted black holes also predict white holes. We haven't observed one. We have nothing beyond the mathematics to suggest it, but there is evidence that it could exist. Doesn't mean it does. As far as we know, they don't, but as far as we know, they don't. They still very well could. They are possible. So there was other things that I wanted to look at too. This story here, how there's a new theory that could explain 95% of the cosmos. And this gets into dark matter and dark energy, which is something that we've dealt with on the show quite a bit. But it says scientists at the University of Oxford have solved one of the biggest questions in modern physics with a new paper unifying dark matter and dark energy into a single phenomenon, a fluid which possesses negative mass. So here it is again, negative mass. And this could explain why we have wormholes and black holes and things like that in the universe, and if this negative mass thing is a factor, they could be traversable. If we accept that, the whirlwind phenomenon in the Bible when angels show up, like in the first chapter of the book of Ezekiel, if we accept the premise that those are wormholes, then we know that they exist and they can connect to higher dimensions. And so it would stand to reason, it would seem, if you can connect a wormhole to a higher dimension, then surely you could connect a wormhole to our own dimensions, our own 3 dimensions. So it's interesting to think about. But so dark matter and dark energy might actually be able to be unified. So it says here, just like what we talked about, if you were to push a negative mass, it would accelerate towards you. This astonishing new theory may also prove right a prediction that Einstein made 100 years ago. Our current widely recognized model of the universe, called the lambda CDM, tells us nothing about what dark matter and dark energy are physically. We only know about them because of the gravitational effects they have on other observable matter. This new model, published today in Astronomy and Astrophysics by Dr. Jamie Farnes from the Oxford E-Research Center, Department of Engineering Sciences, offers a new explanation. Dr. Farnes says, we now think that both dark matter and dark energy can be unified into a fluid which possesses a type of negative gravity, repelling all other material around them. Though this matter is peculiar to us, it suggests that our cosmos is symmetrical in both positive and negative qualities. Now, a couple of episodes ago, we talked about the expansion of the universe. If this theory is true, this could explain why the universe is expanding the way it is. Or if you accept this particular interpretation of a Bible verse, why God is stretching the heavens in the way that he is. Now, again, with that Bible verse, we don't know how literally we can actually take that, but it's still interesting to think about. But it might explain if the universe does have this repellent negative mass type of thing happening. That could help explain the expansion of the universe and possibly why it seems to be accelerating. Now, again, I'm not going to rehash everything, but in the expansion of the universe episode that we just did a couple weeks ago, I posed the question. How do we know that it's expanding faster and faster? Because we look at distant galaxies and we can see it expanding faster. But we got to remember when we're looking at distant galaxies, we're looking back in time. So wouldn't that just mean, thousands, millions, billions years ago, whatever your cup of tea is, however long ago, wouldn't it just mean that it was traveling faster back then and it's actually expanding slower now? I don't know, but it's an interesting question. So it says here, the existence of negative matter has previously been ruled out, as it was thought this material would become less dense as the universe expands, which runs contrary to our observation that show dark energy does not thin out over time. Again, it might. It depends on how far back we're looking back in time, and if we're factoring that in when we talk about the expansion of the universe. So I would have the same question for that statement. But it says, however, Dr. Farnes's research applies a creation tensor, which allows for negative masses to be continuously created. It demonstrates that when more and more negative masses are continually bursting into existence, this negative mass fluid does not dilute during the expansion of the cosmos. In fact, the fluid appears to be identical to dark energy. Dr. Farnes' theory also proves the first correct predictions of the behavior of dark matter halos. Most galaxies are rotating so rapidly they should be tearing themselves apart, which suggests that an invisible halo of dark matter must be holding them together. What's interesting is there's a theory, I wrote about this in my book with Tom Horn, Abaddon Ascending. There's a theory that even the Earth actually does have a ring of dark matter around it. So maybe it's not dark matter. Maybe it's this dark matter, dark energy hybrid. Who knows? But it suggests that that this invisible halo of dark matter would be holding even galaxies together. Now, the new research published today features a computer simulation of the properties of negative mass, which predicts the formation of dark matter halos, just like the ones inferred by observations using modern radio telescopes. So Einstein provided the first hint of the dark universe exactly 100 years ago when he discovered a parameter in his equations known as the cosmological constant, which we now know to be synonymous with dark energy. Einstein famously called the cosmological constant his biggest blunder, although modern astrophysical observations prove that it's a real phenomenon. It notes, dating back to 1918, Einstein described his cosmological constant, writing that a modification of the theory is required such that empty space takes the role of gravitating negative masses, which are distributed all over the interstellar space. It is therefore possible that Einstein himself predicted a negative mass-filled universe. And if that is the case, that would explain a lot of the things that we talk about on this show. It would actually help explain quite a bit. So Dr. Farnes says, quote, previous approaches to combining dark energy and dark matter have attempted to modify Einstein's theory of general relativity, which has turned out to be incredibly challenging. This new approach takes two old ideas that are known to be compatible with Einstein's theory, negative mass and matter creation, and combines them together. The outcome seems rather beautiful. Dark energy and dark matter can be unified into a single substance, with both effects being simply explainable as positive mass matter surfing on a sea of negative masses. End quote. This might also help explain things like brains and universes floating on brains that in turn float through hyperspace. That might be the repellent factor, because string theory even says that there are certain particles that are bound to our universe, that they cannot move. But particles like gravity can traverse dimensions just on their own. So maybe there is a type of negative gravity or a negative mass effect that allows for that type of thing. Proof of Dr. Farnes' theory. will come from tests performed by a cutting-edge radio telescope known as the Square Kilometer Array, or SKA, an international endeavor to build the world's largest telescope in which the University of Oxford is collaborating. Dr. Farnes adds, quote, "There are still many theoretical issues and computational simulations to work through, and Lambda CDM has a nearly 30-year head start, but I'm looking forward to seeing whether this new extended version of Lambda CDM can accurately match other observational evidence of our cosmology. If real, it would suggest the missing 95% of the cosmos had an aesthetic solution. We had forgotten to include a simple minus sign." So we'll see. But again, I think that a big part of this, too, is factoring time into it, especially with the expansion of the universe. But if you factor time into it plus negative mass, then you might really have something. There's another theory about wormholes. Physicists proves wormhole travel is possible, but it's not what you think. Now, I want to just briefly touch on this just to show that there is not a consensus when it comes to wormhole theory. There's not really a consensus at all. This one is strange. This one is weird to me, and I don't fully get it. I don't fully understand, but we're still going to talk about it anyway, and then maybe you guys can help make sense of it. But it says a Harvard physicist has likely ruined the dreams of many a science fiction fan by claiming a real wormhole would be useless for deep space travel. Films such as Stargate and Interstellar have used the concept of a wormhole, tunnels in curved space-time that connect two places, as a core tenet of travel to distant worlds. However, new research has come to spoil the party for science fiction fans by claiming that while wormholes exist and travel would be possible, they would be a waste of time. Presenting these findings, it's Harvard physicist Daniel Jafferis, along with Ping Gao at Stanford University's Aaron Wall. So they said rather than being a portal for fast travels, wormholes would be incredibly slow. So it says, Jafferis said, quote, "It takes longer to get through these wormholes than to go directly, so they are not very useful for space travel," end quote. However, rather than this research being for nothing, he believes that finding a way to construct a wormhole through which light could travel could help physicists in their efforts to create a theory of quantum gravity. He added, quote, "The real import of this work is in its relation to the black hole information problem and the connections between gravity and quantum mechanics." So let's skip ahead a little bit. So Jeffers said, quote, "From the outside perspective, travel through the wormhole is equivalent to quantum teleportation using entangled black holes," end quote. The latest theory is based on a setup first devised by Einstein and Rosen in 1935 that would later be known as a wormhole, or an Einstein-Rosen bridge. It's another thing it's called. But because the wormhole is traversable, Jeffers determined it may be possible to extract information. It gives a causal probe of regions that would otherwise have been a horizon, a window to the experience of an observer inside a space-time that's accessible from the outside. I don't know what any of that means. And then it goes on. There's a little bit left in the article, but it doesn't really explain why, if a wormhole exists, why that means that it would take longer to go through it. I haven't seen any, at least not in this article, I haven't seen any kind of explanation for that, so I don't really understand that. But it's just to show that there is not a consensus on wormholes, and apparently there is a model of wormholes that would actually take longer if you travel through the wormhole than if you were to just go there directly. So I don't know what to do with that, but I thought that it was worth mentioning just to show that there are other theories about wormholes out there. Now, what about black holes and the possibility that they could actually be colliding wormholes? We have a couple of stories on this. There's a couple of headlines. One from Daily Galaxy, and are they both Daily Galaxy? Oh, one from Live Science. And they're basically kind of talking about the same thing, so we'll probably just hit these both together. But it says, when two wormholes collide, they could produce ripples in space-time that ricochet off themselves. Future instruments could detect these gravitational echoes, providing evidence that these hypothetical tunnels through space-time actually exist, a new paper suggests. LIGO, the Laser Interferometer Gravitational Wave Observatory, has already detected space-time ripples called gravitational waves emanating from merging black holes, discoveries that led to the Nobel Prize in 2017. So it says here, these exotic objects still pose theoretical problems. For instance, they seem to be inconsistent with the laws of quantum mechanics. One way to resolve these problems is if black holes were actually wormholes. So wouldn't that be interesting if black holes and wormholes are actually the same thing? You know, we theorize about wormholes. One, as far as we know, has never really been discovered, at least not scientifically. But what if black holes are actually wormholes? So it says, one of the main features of black holes is the event horizon, a region of space-time beyond which nothing can escape, not even light. If you throw anything into the black hole, it's lost forever to an extent. Stephen Hawking discovered that, thanks to a phenomenon known as quantum tunneling, black holes could actually produce a tiny bit of radiation, which would come to be known as Hawking radiation. Over a long time, black holes could even evaporate away due to this radiation. Now, Amber Stuver, an astrophysicist at Villanova University in Pennsylvania, said, quote, but what comes out of this is random. In quantum mechanics, if you know everything about a particular system, then you should be able to describe its past and its future, end quote. But because any information that goes into the black hole is gone for good, an event horizon doesn't jibe with quantum mechanics. So to resolve this, some scientists have suggested that event horizons don't exist. So instead of abysses from which nothing can return, black holes actually could be a host of speculative black hole-like objects that lack event horizons, such as boson stars, gravistars, fuzzballs, and even wormholes, which were theorized by Albert Einstein and physicist Nathan Rosen decades ago. So this just goes on to say that it could be, black holes could be wormholes, they could be colliding wormholes. This one says that black holes don't exist at all, and then these ripples of space-time were created by wormholes. So in a sense, wormholes and black holes are the same thing. It says the confirmation, and this is from Daily Galaxy, it says the confirmation of echoes in the LIGO or Virgo signals would be a practically irrefutable proof that astrophysical black holes don't exist. Time will tell if these wormhole echoes exist or not. Pablo Bueno with KU Leuven University in Belgium says, quote, if the results were positive, it would be one of the greatest discoveries in the history of physics. Wormholes do not have an event horizon, but act as a space-time shortcut that can be traversed, a kind of very long throat that takes us to another universe. So the scientific collaborations, LIGO and Virgo, have detected gravitational waves from the fusion of black holes, inaugurating a new era of study of the cosmos. But what if those ripples of space-time were not produced by black holes, but by other exotic objects? So last June, a team of physicists suggested an alternative, wormholes that can be traversed to appear in another universe. So this would be actually a wormhole between two universes, two parallel universes. It's like if you have a stack of a sheet of papers this time, and you say you turn one around and you fold it over the top of another, and then you create a hole. That hole would be the wormhole, and every sheet of paper in the stack is a parallel universe. So that's the idea that they're going after in this model of the universe, or what's called the multiverse. And again, I just like to remind people, when we talk about multiverse, you don't necessarily have to mean there are parallel versions of ourselves, and for every choice that you could have made in your life, there's another version of yourself that made that choice in another universe. That is one particular branch of multiverse theory, but there are several branches. That one I don't agree with. I don't think there's any reason to believe that. Now, I do believe that our universe could be one of several, but it doesn't mean that any of those universes even have to be inhabited. It's like if you have a book, but one page in the middle, or anywhere really, one page has writing on it, and the rest of the pages are blank. But it's still a book, it's still a 3D object. What I think is actually going on is our universe is one slice in God's amazing creation, and when we're in eternity, we'll actually see that all the cosmos, all of the creation, is actually a hyper-dimensional creation. It's more than just the 3 dimensions that we can that we can experience. So, but again, I've written about that in many books, and I have talked about it a lot on this show before. So I don't want to get too far off on that. But the interesting thing is that black holes and wormholes might actually just be the same thing. So that's interesting. Leave me a comment. I want to know what you think about that. Next, quantum theory illuminates wormholes, observing a distant point of the universe in 4 dimensions. And this kind of goes back to what we were talking about before. So it says modern concepts of the universe provide for the existence of wormholes, unusual curvatures in space and time. Physicists imagine a wormhole as a black hole through which one can see a distant point in the universe in 4 dimensions. Now, I'm going to come back to that in just a minute, but there's something important to note with that. So it continues to say astrophysicists are still unable to determine the shape and sizes of black holes precisely, let alone theoretical wormholes. A physicist has now demonstrated that the shape of a wormhole can be calculated based on an observable physical characteristics. All right, and then you can read the rest of this article at Daily Galaxy if you want, but the main reason I brought up this article was mainly to deal with this statement here. Physicists imagine a wormhole as a black hole through which one can see a distant point of the universe in 4 dimensions. Now, if you were able to actually look through a wormhole, you might be able to see a distant point in the universe, but you wouldn't see it in 4 dimensions. So I don't know why this statement is phrased the way it is. Now, it might traverse through 4 dimensions to get to the other place in our 3-dimensional universe. That could happen, just like the folding a sheet of paper kind of thing that we talked about many times before now. That could happen, but it wouldn't change your perception. You wouldn't be able to see in 4 dimensions. You would still see a 3-dimensional universe. Interestingly enough, even if you were able to see into a higher dimension, your brain can't handle that much information, and it would look like to you, it would look like a 3-dimensional universe that's constantly shifting and changing shapes and changing colors, and I mean, it would be like, it would be really trippy. But your brain wouldn't actually see that 4th dimension. So I wanted to just mainly deal with that statement in light of what black holes and wormholes might be. Even if a wormhole does travel through an extra higher spatial dimension, that doesn't mean you would actually be able to see it. You would see it as if it were a 3-dimensional universe. Just like if you took somebody, if there was a 2-dimensional entity and you lifted him out of his universe into ours, he's still seeing everything as just like lines in front of him. But as you're moving him around, all those lines are changing shape and changing color because he's seeing everything in front of him, but he has no up or down. So it wouldn't change your perception. You would still, you could see a higher reality, but you would see it as still a 3-dimensional universe because your brain can't process 4 spatial dimensions. You would see it as 3, but all of the objects, like as you walked through it, you would notice as you're moving through this 4-dimensional reality, everything around you is changing shape and changing color, and it would be really weird. It'd probably be pretty horrifying. All right, last thing we're going to look at before we close out. This is something I talked about in Abaddon Ascending. Big Bang vanishes, quantum theory described as eternal universe. And I want to talk about this because there could come a day where we turn on the news and physicists say, hey, it's been discovered the universe actually had no beginning, meaning there is no God, there can't be. The universe was never created, it's actually eternal. There are physicists that are working so hard to try to prove this eternal universe thing, and it's simply not true. There was a theory proposed a while ago called rainbow gravity theory. You can still look it up. I still have some blogs out online about it. But it suggested that when light travels into a black hole, the intense gravity, it operates on different wavelengths in different ways. So it suggested that when light enters a black hole, it'll pull some of the wavelengths faster than the other, so you would actually see a rainbow go into the black hole and not a beam of light. And somehow, and I've never understood why this is the case, I've never found anything that's explained it in any kind of way that I can understand, but somehow, if rainbow gravity theory is true, then it proves that the universe is infinitely old. I don't know how they make that leap. I've read several scientific papers on it, and I can make sense of the scientific papers. I understand how maybe gravity would work differently on different spectrums of light. That makes sense to me. I fully understand that, and I actually agree that it probably does. I don't understand why that would lead to the assumption that the universe is infinitely old. That I've never understood that. I've never read anything written that actually explained that connection. But that's what physicists are saying. So There could come a day that rainbow gravity theory is proven true, and then you'll have physicists and scientists saying that this means there was no beginning to the universe, meaning the universe is eternal, meaning there's no need for a creator. There's no need for God to create anything. There was no in the beginning. Now, I would suggest that I don't believe that the universe is infinitely old at all, and I'll mention why in a minute. But even if it was, it could have still been created. All it means is that it was created outside of time. Like eternity is a state outside of time. Eternity is not infinity. But physicists and scientists will make this conflation all the time. They'll say that eternity and infinity are the same thing. Eternity is a state outside of time. Infinity is, in regards to time, infinity is time everlasting, time without end. You could have an eternal universe that would just be created outside of time. The universe could be eternal, and then maybe our section of it is just the section that's within time. That could be. But infinite time, I don't believe could possibly exist in the three-dimensional reality that we know today, or even in a 12-dimensional reality. I don't see how infinite time could exist. We'll get into it. We'll get into that in a little bit, but I want to go over some of this article. And again, remember that the reason that these physicists bring this up is they're desperately searching for a way around having to admit that there's a creator, having to admit that there was a point of creation, because that's one of us being Christians, that's one of our strongest arguments in favor of there existing a God. If physicists can prove that the universe exists without needing a cause, that it's just an effect without a cause, then they can dispel with God completely. At least that's what they think. But it's physically impossible. It says, an intriguing new theory suggests there was no Big Bang singularity, no starting point, and points at the possibility that the universe had no beginning. By the way, this is not a new theory. This is actually, it's not letting me highlight it. There we go. This is not a new theory. This is a pretty old theory, and it has been debunked plenty of times in plenty of different ways, and every time that scientists will try to come at this from a new angle, it gets debunked by another scientist. So this is not a new theory. They might be coming at it in a new way, but the theory is pretty old. So it says, the Big Bang singularity is the most serious problem of general relativity because the laws of physics appear to break down there, according to Ahmed Faraj Ali at Egypt's Benha University. Ali and co-author Soria Das at the University of Lethbridge in Alberta, Canada, have shown in a paper published in Physics Letters B that the Big Bang singularity can be resolved by their new model, in which the universe had no beginning and no end. So it says, it's widely known that Einstein's theory of relativity is successful in describing astrophysical and cosmological phenomena. According to the theory, physical laws must be defined at every point in space-time. However, the theory has a serious physical and mathematical problem known as the Big Bang singularity that predicts that our universe began from an infinitely dense point at which the laws of physics break down. I might have a version of the Big Bang that seems to make sense to me, where God spoke and things came into existence and probably flew all over the place, but I don't believe that it was an infinitely dense point, because you can't have infinity in physical reality. Now, they wouldn't say that point is within physical reality. They would say that that point is physical reality, and then physical reality expanded out. There would be nothing for that point to be in. Now, and that's kind of ridiculous too. But it's something that's like kind of outside of space, sort of. But the problem is, you're still using infinity to describe physical reality in some way, and that's impossible. Carl Gauss, famous mathematician, even has been quoted as saying that it's basically, if you have infinity as your answer to a scientific or mathematical problem, you messed up somewhere. And the reason is because we have definites. Infinity is indefinite. We have definites, meaning reality is definite. And in no part of the indefinite can exist within the definite. Now, I know that's confusing, but here's an example so we can kind of get our heads around this. Let's take percentages. If the universe is, say, infinitely old, no beginning, no end, just is, which actually that is a description of eternity, but let's go with the physicists. Let's just say the universe is infinitely old. You can go back in time forever, and you can go forward in time forever. What percentage of the infinite lifespan of the universe, what percentage is this second? What percentage is the age of the universe, or the age of the earth, let's say? We know that the earth isn't infinite. The earth had a beginning, the earth had an end. Some people believe the earth is like 4 billion years old. Some believe it's about 6,000 years old. But let's just for sake of argument, let's say that the earth is 4 billion years old. What percentage of infinity, of the entire age of the universe, what percentage is that 4 billion? There is no number you could put on that. It's a nonsensical question. Yet the 4 billion exists. That 4 billion exists within something it can't exist within. Because what percentage would you say? 1%? Well, what is 1% of infinity? It's still infinity, right? So whatever number you try to put on that 4 billion, say it's 0.000000001 of infinity. Okay, that percentage of infinity is still infinity, right? Same goes for space. It's not just time. Same goes for space. Let's say the universe is infinitely large. Some scientists will say this. Even let's add all the extra dimensions you want. Let's add all of it. Let's put in hyperspace. Let's put in everything and say that all of that is infinitely large. What percentage of that thing that we call the universe or the multiverse or whatever, what percentage of that is our solar system or is our galaxy even? You say our galaxy is like 1/1 billionth or 1/1 trillionth of the universe, a universe that's infinitely large. Okay, but still 1/1 trillionth of infinity is still infinity. That would mean that our galaxy would have to be infinitely large. That would mean you and I would have to be infinitely large. That would mean the atoms in our bodies would have to be infinitely large. Everything would be equal and everything would be infinite and nothing could exist. So it all breaks down, like it's nonsense. So that's why I'm really against this idea about the universe being, infinitely old or being eternal or something like that. It does cut out God, but it also shows that if you don't have a God that creates the universe, you have this type of ridiculous, illogical universe that could not exist the way that our universe does exist. Because again, you would have things like atoms would be the same sizes as universes and they would have no end, and nothing could exist in that. Not according to the laws of our current universe. So how did our current universe get here? Without a creator God, it's just illogical. So at that point, it's like, well, which God is it then? There's a bunch of different world religions. Which God is it? And I think that if you really look at it logically, philosophically even, you can use reason and logic alone, and you will come to a God that has attributes an awful lot like the God of the Bible. You don't even, if you're going to follow that train of thought, you don't even need the Bible to begin with. I mean, you should, but you don't need it. There were philosophers, Greek philosophers, that just using reason and logic alone by observing their universe, they came to the conclusion that a God would have to exist that sounded an awful lot like the God of the Bible. Now, of course, not all of them, worshiped the God of the Bible or anything, but I think that that's what made it easier to witness to them when the apostles went into Greece and stuff and witnessed to those people. I think it made it easier because I think that they realized, oh, this is the God that we've been looking for. The God of the philosophers is actually the God of the Bible when you really look at it. They share a lot of attributes. So you can use logic and reason to get, you can get quite a ways there. But again, that's for scientifically minded people. With most people that you witness to, you show them the Bible, you read about Jesus, you tell them about salvation and sin and repentance and all that kind of stuff. But I'm just talking about just from a purely scientific, even materialistic point of view. as long as you don't have roadblocks. A lot of materialists have these roadblocks that as soon as you start getting into spiritual territory, it's done because we're materialists, they'll say. But you can even use just the laws of the universe, just the laws of the universe, the laws of materialism, to actually show that materialism in itself doesn't really work either. There has to be something more. And actually, if you want more information on that, I'll probably have to do a Peck report on just that, the philosophical arguments for God using science and materialism. But I have a new book coming out that I wrote with Allie Anderson-Henson and Donna Howell, my co-host on Chalk Talk. It's called Afterlife. It'll be out early next year. And in a chapter of that book, I go through all of these arguments and show how you can literally look at a cup on a table and just observe what is going on here. You can observe this in a lot of different ways, and you can come to the conclusion that a God must exist. And I know that sounds weird. But they're actually old, really ancient arguments. It's old philosophical arguments that have been largely discarded. And when you go to universities and things like that, you'll see a lot of straw man arguments based on these ancient philosophers. But when you really look at what the philosophers said, they do, over time, they do kind of come to the realization, they describe a type of creative God that is very similar to the God of the Bible. So it's interesting that you can just look at nature, you can just look at creation and come to the conclusion that there is a God. The Bible says that. The Bible says that people are without excuse because you can look at creation, you can see creation, and you can know there must be a God. And I show that in the book. So you'll have to look forward to that. But I did want to bring this up, and I did want to warn all of you that this type of stuff is coming. It's going to be coming more and more. You're going to hear more and more in the news and in science journals, and it's going to bleed into mainstream science and even mainstream science fiction, and that's going to bleed into the culture. This idea of an eternal or an infinite universe, both in space and or time. So keep an eye out for that. Know the arguments on why it's wrong, because I believe that that's going to be used as a weapon against Christians to show how ridiculous our God is. So now is the time to study up. Now is the time to get a hold of the arguments on how infinity is actually ridiculous, how infinity makes no sense in physical reality. As a mathematical concept, as just some weird abstraction in the ether that isn't really applicable to physical reality, fine. But something within actual physical reality can't be infinite, otherwise everything would be infinite. Because everything is a percentage of something else. Everything is a percentage of something bigger. So your hand is 1-2% of your body. Everything is a percentage of something else. So because of that, infinity cannot work, because any percentage of infinity is infinity. And not everything is infinite, not everything is equal. All right, everybody. Well, I would love it if you would send your questions. If you have a question for the show or a comment for the show, I would love it if you would send that to jpeck@skywatchtv.com. Also, don't forget to subscribe to this channel. Click on the bell for notifications. And if YouTube still doesn't notify you, just know that every Thursday morning at 9 a.m. Central, you will get a new episode of Into the Multiverse. All right, everybody. Thank you so much. Until next time, take care and God bless.
When did the government alien programs originate and why? Who were the Collins elite, and were they exposing the dangers of such programs? What exactly did these black projects involve? Learn the astonishing answers to those questions and so much more. Skywatch TV is proud to announce the Higher Entities Ultra Collection. This special offer includes the new Fall Brothers feature film, Higher Entities, The Lost Tapes, which is a live-action documentary including up-close and personal discussions with former FBI agents, Department of Defense consultants, best-selling authors, and seasoned research professionals that deliver intimate testimonies of disclosure, which put you face-to-face on location and in the conversation, featuring Justin Fall, Dr. Thomas Horn, Ray Boucher, Derek Gilbert, Stan Deo, Darren Geisinger, Chad Riley, and Wes Fall. But that's not all. You'll also receive the top-secret 5-volume DVD collection, Project Stargate. This unprecedented series of never-before-released confidential interviews features 12 of the world's leading authorities on UFOs, so-called aliens, gods, and the coming day of contact. You'll be amazed as we go behind the scenes to ask experts what they really believe is coming. Watch as men with security clearances like the late Dr. Chuck Missler share for the first time what they know. Then take notes as Dr. Michael Heiser, the late Chris Putnam, Russ Dizdar, Joe Jordan, L.A. Marzulli, Daryl Sims, Gary Stearman, Joyce Aarons, and others as they weigh in on what will soon cause the world to stand still in awe. Project Stargate holds a retail value all by itself of $150, included now for a limited time in the Higher Entities Ultra Collection. Sold separately, this Ultra Collection holds a retail value of $175. Yours now for your donation of only $35 plus shipping and handling. So take advantage of this incredible offer now and receive all 5 Project Stargate DVDs along with the new Higher Entities documentary for your donation of only $35 plus shipping and handling. Now at the Skywatch TV store. Order the Higher Entities Ultra Collection online or call 1-844-750-4985.